Howdy, Mr. Sutton here with the AB Calculus 4-1 Extra Practice number 5 solutions on extreme values of functions. For this problem, we want absolute extremes for this polynomial on the interval from -1 to 1. We're going to use the candidates test, so we're going to have to definitely check out -1 and 1, but maybe there's some other critical values in between that we also need to look at. So to find those, we take the derivative of our function, which is 4x cubed minus 6x, and then we're going to set that equal to 0 to solve for critical values. We can factor out a 2x from this. That would leave us with a 2x squared minus 3. And then I know that I'm going to have x equals 0 is going to be one of the solutions. And for the other solutions, if I add 3, divide by 2, and then square root both sides, plus or minus radical 3 over 2 would also be a possible solution. But now, in terms of critical values, 0 is definitely on the interval from -1 to 1, but how about these radical 3 over 2's? Well, radical 3 over 2, 3 over 2 itself is a number bigger than 1. The square root of that then is also going to be a number that's bigger than 1. So that means that these plus or minus radicals will not be inside the interval in question here. So we don't have to look at them. We just have to look at 0. So only 0 then will be one of our candidates. Let's test our candidates out now. So I'll check out f of -1 first. So that's going to be 1 minus, let's see, this is 3 times -1, so 1 minus 3, which is going to be -2. -2 plus 1 is -1, so that's -1 total. Now let's check out 0. That's an easy one to plug in. F of 0 is just going to be the constant, 1, because all these other x terms go away. And then finally, let's check out f of 1, the other endpoint. That's going to be 1 minus 3, which is -2, plus 1 is going to be -1, so same as -1. And we see here that these -1s are tied for the absolute min, and then this 1 is our absolute max. On this problem, I've got this polynomial that I want to find the absolute max for on the interval from -2 to 3. We're going to use the candidates test on this one, so we're going to have to test out the endpoints, -2 and 3. There might also be some critical values in between that we have to test as well. To see if there are any, we take the derivative of this, f prime, and see what zeroes that out. So I've got 3x squared, and then this next one, this is going to be, let's see, minus 3x minus 6, and we'll see where that equals 0. So I can factor a 3 out of all these to make my life a little easier. That's going to be x squared minus x minus 2 equals 0. There we go. And then, let's see, two numbers that multiply to -2 and add up to -1. That would be x plus 1 and x minus 2. So we see this is going to be true at x equals -1 and x equals 2. -1 and 2 are both on the interval from -2 to 3. So that means we have to test out the endpoints plus 2 more critical values. All right, well, here we go. And this was a no calculator question, so we're going to have to be able to do this by hand here. So f of -2, we'll start with the left endpoint. Plugging that in term by term, we've got -8, because that's -2 cubed, so -8. And let's see here, this is going to be 4 divided by 2 is 2, times 3 is 6, so -6. And then let's see, -6 times -2 is 12. This is -14 plus 12, which is -2. Next thing to test out, we're going to try -1. Plugging that in, we've got -1. This is going to be minus 3/2 plus 6. So let's see here. This is, we'll do the non-fractions first. So -1 and 6 gives us 5. So we basically have 5 minus 3/2. Well, that's like having 10/2 minus 3/2, which is 7/2. All right, let's keep going. We need to try out 2 next. So that's going to be 8 minus, let's see here, this is 3/2 times 4, so that's going to be minus 6. And then we have minus 12. So this is -2 minus another 12 is let's see, actually, yeah, 2 minus 12 is -10. There we go. And then last one, we've got 3. Got to try that out. So that's going to be 27. And then let's see here, this is 3/2 times 9, so that's going to be 27/2 that we're subtracting. And then finally, minus 18. Well, again, let's do the non-fractions first. 27 and -18 gives me 9. 9 is really 18/2. So I have 18 halves minus 27 halves for a grand total of negative 9 halves. Now, out of all these, we were looking for the absolute max. So since I have negatives and positives, obviously none of the negatives is going to win. It's actually, there's only one positive, 7 halves. So that ends up being our max. Choice C. For this problem, I'm given this weird kind of x cosine sine hybrid formula, and I want to know the absolute max for this function on the interval negative pi over 2 to 2 pi. So I've got some critical values that I'm going to be looking for in just a moment, but just sort of strategizing for what's ahead, I'm going to use the candidates test out all the possible absolute maxes here, and the endpoints are also going to get tested for this. So we'll test those in just a bit, but let's see if we can find some critical values. For that, I need to find f prime and set it equal to 0. So for f prime, I'm going to need a product rule on this x times cosine of x. So let me get the box and ribbon here. I've got factors of x and cosine of x. The derivatives are going to be 1 and negative sine of x. Using the ribbon to multiply that out, I've got cosine of x minus x sine of x. And then we still have the derivative of negative sine we have to take, and that's negative cosine. Well, this is convenient. Cosine and negative cosine cancel out, so our derivative is just negative x sine of x. That's not going to be undefined anywhere, so we just have to figure out where it equals 0. And there's a few spots. Obviously 0. If you plug 0 in for x or the other x, either of those zeros is going to zero this thing out. But there's also some other spots. So although this negative x is only 0 at x equals 0, sine of x is going to have a value of 0 at multiple places. This is the y value on the unit circle, so any angle where you're on the x-axis is going to give you a value of 0. So we only have to, so there's an infinite number of those, but we only have to look between negative pi over 2 and 2 pi. So definitely pi, sine of pi is 0, and also sine of 2 pi counts because it's one of the endpoints, but we'll just list it there. All right, so we have to use a few things that we're plugging in here. We've got negative pi over 2, we've got 0, we've got pi, we've got, as an endpoint and a critical value, we have 2 pi. So let's plug all of those into the original function and see what happens. Starting with, we'll start with the hard one, negative pi over 2. So plugging that in here, cosine of negative pi over 2, since we're on the y-axis, the x value on the unit circle is 0, so that first term is just gone if you plug in negative pi over 2. Sine of negative pi over 2 is negative 1, but it's negative sine, so that becomes a positive 1 then. All right, let's check out 0 next. That obviously zeroes out the first term, and actually the second term, sine of 0 is 0, so that's 0 overall. For plugging in pi now, well, sine of pi is 0, we know that for sure. Cosine of pi is negative 1, so that's going to be a pi times a negative 1, which is negative pi. And then finally, plugging in 2 pi, again, sine of 2 pi is going to be 0, but now we have 2 pi times, well, cosine of 2 pi is 1, so that's just 2 pi overall. And now we were looking for the absolute max. It's always good to reread it and make sure we're looking for the correct one. So what's the highest value out of all of these? Well, definitely it's not going to be the negative. There's positives, so it's not going to be 0. So it's down to 1 and 2 pi. We know pi is about 3.14 and some change, so definitely 2 pi is the winner on this one, giving us choice B. For this one, we're trying to figure out the absolute max for this polynomial on the interval negative 6 to 6. So we know using the candidates test, we're going to have to try out the two endpoints. Let's see if there's other critical values that we also have to try out, because one of those might be the winner. So to find the critical values, we take the derivative and set it equal to 0. So we have negative 3x squared plus 6x plus 24. Setting that equal to 0, we can factor out a negative 3. That would leave us with x squared minus 2x minus 8. All of that equals 0. And then things that multiply to negative 8 and add up to negative 2. That would be x plus 2 and x minus 4. So the x values then that solve this are going to be negative 2 and positive 4. Okay, are those on the interval from negative 6 to 6? They are. So we have to try out these two critical values along with the two endpoints. All right, candidate test time. Let's plug in negative 6 first, and we're just going to go term by term here. So we have negative 6 cubed is negative 216, but we have a negative out in front. so that's positive 216, plus we've got 3 times 36, so that's going to be plus 108, plus, let's see, negative 6 times 24, that's going to be negative 144, yep. Adding all this together, so we have to do this without a calculator, unfortunately. Let's see here, 216 plus 108, that's going to be 324, minus 144 is going to be 180. Next, let's try out negative 2. Hopefully that'll be a little bit easier with the mental math. So we've got, let's see, negative 8, so that's positive 8. This is going to be 3 times 4, so 12. This is negative 48. 20 minus 48 is negative 28. So that's definitely not the winner. Let's try 4. F of 4. That's going to be negative 64. And then 3 times 16 is 48 that we're adding. 4 times 24 is 96. So negative 64 and 48, that's going to be negative 16 plus 96 is 80. Also not the winner. So far, f of negative 6 is looking pretty good. But we got one more candidate to try out. Let's try f of 6. Maybe this one will beat out negative 6. So we have negative 216. So that's not really off to a good start. After that, though, we have 3 times 36. Again, that's 108. 6 times 24, now that's positive 144. So that's different. So we have, let's see here, let's add the positives first. So this is going to be 252 minus 216 is going to be 36. Also not the winner. So after all of this work here, we find that negative 6 gave us the highest value. 180 then is the absolute max, giving us choice D. For this problem, we're given this sine of x cosine of x over x squared minus 4 function on the interval negative 2 pi to 2 pi, closed interval, and we want to know on which of these closed intervals is the function f guaranteed by the EVT to have an absolute max and min. So recall that the extreme value theorem guarantees an absolute max and min if your function is continuous on a closed interval. Now, all of these intervals here are closed, so obviously that's not going to be an issue. But we have to see if our function is continuous on various intervals. Well, probably the easiest way to do that is to look for discontinuities. There's nothing at issue with sine or cosine, so it's really just dividing by 0 that we have to be worried about. And we see that we're going to have discontinuities if x is either negative or positive 2. So if we have intervals that have negative or positive 2 in them, we can quickly eliminate them because EVT guarantees nothing if you have discontinuities. So looking at our first one here, negative 2 pi to 2 pi, well, that contains both of these discontinuities, so that's an issue. Negative 2 to 2, well, the discontinuities are at the endpoints, but we need continuity on the closed interval, so this doesn't work either. Negative 1 to 1, that's between our discontinuities, so that's actually a pretty good interval there. No discontinuities on this one. And then this last one, pi over 2 to pi, well, that's going to contain 2 because 2 is between, this is about like 1.57 and 3.14. So only negative 1 to 1 has no discontinuities. So only choice C then is guaranteed by the extreme value theorem.